Here in the Isle of Man, my local Poundland alias Deals, Dealz, was stocking these Amazon products. Well, I say Amazon products, it's for Amazon products. It's basically a charger base which supposedly contains a 10,000 milliamp hour cell, and you stuff your Amazon Echo type thing down the inside of it. Let me just shine a light down inside so you can actually see what's down there. And it's got a little plug that can push into the side of it. And it's got a button to eject it. What does that do? Oh, there it is. There's the ejection mechanism down there. So you stuff it down the inside, and it basically lets you take your Amazon Echo out with you if you want to do that into the garden or whatever. So here's a little port at the side that plugs into the side of the device. It's got two charging ports. It's got a micro USB charging connector, but it's also got the connector that takes the original I'm guessing the original Amazon connector. I have tried shoving that in there. You can do it if you use enough force. Nothing happens. On the front, it's got something that resembles an ordinary power bank indicator. It's got the button and it's got the 4 little level indicator LEDs. So let's open it. That's why I got it. I want to see, does it actually contain a 10,000 milliamp hour cell? I'm guessing that since it says it's the generation 2 of these, that it may be that the newer versions, it's not compatible with the newer versions. That's how it's ended up in Poundland at that price. So I do see some screws down the bottom here, but they're well out of reach. But I'm going to try and take them out, and it's going to be a bit fumbly, so I'm going to pause momentarily while I do that. I'll be back in a moment. The screws are out. That took quite a while, I have to say. I'm glad I paused there. The base is coming off. Not sure how easily it's going to come out here. Oh, there we go. Ooh, interesting circuitry. Now, it's worth mentioning, well, that is one big. That is worth getting for the batteries. I'm going to have to keep in mind here, these batteries are fully charged. This cable is going round a support here. It's going round one of the pillars to give it extra strength. It's worth mentioning the output voltage in this. Where does it actually connect onto the circuit board? I guess it'll be those two connections. Let's bring in the meter. Let's bring in the meter and focus down onto there. Has that focused down onto there? It's hard to say. Let's zoom up. Yes, that looks pretty. That looks pretty well focused. That is pretty good, I have to say. I'm trying a warmer setting in the image. I could also probably brighten the image up a little bit. Just experimenting the new camera. I shall get rid of this bit. It's all needing to be put out the way here. So I'm guessing those two connections are for the output. And if I probe them, I get about 8 volts, but if I press the button to wake it up, oh, I still get 8 volts, so maybe that's not going out to the lead. I thought that was a higher voltage. Hold on. Maybe I'm not on the wrong connections. So let's put that on there and press the button. Not sure. I tested it earlier on. I'm not sure what the difference I've done here is. But it measured about 15 volts output, I think. Am I right in saying it was 15 volts? Do I have to hold it and to wake it up? Oh, there you go. You hold it to wake it up. Okay, 15 volts. So I'm not sure what current it can supply at 15 volts. Taking a look at the circuitry on board. Oh, there's a little spring to add to my collection. I'll try and not drop it on the circuit board. Looking at the circuit board itself, I've got those two lithium cells stacked. Are they being charged? Are they just in parallel, I wonder? Oh, you know what? See what I measured just now? That was probably the battery. Oh, I'm going to have to bring the meter back in then. So that would be two cells in series then. That's interesting because it means that the USB charger is boosting the voltage up. So if I stick it on here, it's showing about just short of 8.4 volts. That is the two lithium cells. They are in series. Okay, let's pause momentarily. I'm going to take a picture of this. We'll take a closer look at the picture and we'll see what circuitry there is. What's worth salvaging? Well, I know it's worth salvaging. These fat lithium cells are worth salvaging. They are beasts. That makes it well worth a fiver out of Poundland, quite frankly. But let's take a look at what else we've got on here. That took a while. That took a very, very long while because it's quite a complicated circuit board. Odd things. It turns out that this must be an expensive circuit board as well because it's 3-layer. It's not just double-sided. It's actually got an inner layer, which perplexed me at first because I didn't think it would be a multi-layer PCB. It turns out you've got this little row of plated through holes here are feeding this transistor to turn on this MOSFET, this one to turn on this MOSFET, and this one to turn on this MOSFET. And they're all part of a sort of battery management system. We've got two other regulators. I'll explain. I'll go over them all. What's surprising, given that they've got this multi-layer circuit board, is that there's a cluster of components in the back in the vicinity of the USB input socket, which I would have thought that they'd maybe have just minimalised the amount of components in the back by putting it elsewhere because there's plenty of room in the circuit board and it is 3-layer, but they didn't. I'm not sure why they did that. It may have just been high current paths, I'm not really sure. So we've got two ways to charge the lithium cell. This is the lithium cell. Let's bring the pen in and I'll colour those as to what they are. So this is a positive and that is the negative to the lithium cell. On the output, if I can actually see it, that is the negative and that is the positive. That's the little jack that goes out to charge the Amazon device. I'm not going to say the name of the Amazon device because it will trigger every single one that is exposed to the sound of this video. So what we've got here, and it's quite complex really, it's quite weird. This is a dedicated buck boost charger chip, and I'm guessing from tracing it out that it's taking the 5 volts, which seems to be switched by another something else here, but it's coming up to this and it's getting boosted to actually charge the cell. The other option is to charge it via this jack here, which is the original 15 volts in for the original Amazon product. And it goes via this little step-up circuit here, from what I can see. And that is controlled from over here at this battery management chip. The battery management chip also controls this MOSFET, which seems to be a sort of like a master kill for the battery pack in the event of perhaps detecting an overload or detecting the voltage is too low, or if the voltage goes too high perhaps even. It's just a sort of safety feature. It's got that MOSFET controlled from this chip. This chip is also controlling this MOSFET, which appears to be boosting the supply to the output. But there's also this dedicated boost chip going to the output, and I do not know why they've got those two controls, unless there's some 2 voltage level system available on the output to that the jack to the Amazon device. It's very strange. It took a lot of actually tracing out this circuit. It's really complex. It's an expensive, complex circuit. My summary of it there, just that number of the little converter, like 5 to 15 to actually charge the battery from the USB. This one to charge the battery from the original power supply. And then these two outputs is basically just sort of making it a bit trivial. But it took a lot of reverse engineering. But that is done. Let's take a look at the battery. The battery, it says on it 3.7 volt, 10,000 milliamp hour. Now, keep in mind that this is a 10,000 milliamp hour battery bank. That's quite big. And that cell inside is 3.7 volt. I'm wondering if they're just treating this as the two cells stacked together as maybe they're 5,000 milliamp hour each, but you'd normally expect, because they've got them in series, to make an 8.4 volt cell. It makes you wonder if they've just classified the whole lump as 10,000 milliamp hour at 3.7 volts, which case each would be the 5,000 milliamp hour. It's not too hard to take the battery out. I'm not going to stick it back in. It's got a sticky pad, but fortunately, it's the type that if you just gently apply a bit of upward pressure, it it doesn't stick too tightly. It has pulled the package up. It always does that. I hate that when you're trying to get lithium cells out and you don't want to rip the packaging or damage it, but it does pull it and sort of pucker it a little bit, but it doesn't really affect the cell. So now, I think we need to investigate this. Normally I discharge cells before I take them apart. This is a terrible idea. The explosion containment pie dish is also absolutely stuffed with lithium cells already. What could possibly go wrong? I shall tip them out onto the floor. They are now got a big pile of suspicious lithium cells on the floor. And the explosion containment pie dish is ready for if we have an incident with this one. Right. Let's get a sharp knife. This is basically bomb disposal at this point. It's a bit freaky. I've got scissors. I've got a sharp knife. Where is the sharp knife? I saw my brother Ralph playing with it earlier on. He managed to actually get it airborne and just narrowly missed hitting me with the open knife. That's very Ralph, by the way. It's this knife, the maker knife. He was, whirling it around while it was open. That's not a good idea, apparently. Right. Let's try and slit this plastic without going into the cells themselves. Theoretically, I should be getting the tape off the top. There is a protection circuit board. It all goes quiet because it really is one of these things. If this goes wrong, I'll have flames. Oh, it's bad enough that I'm going near the output terminals there. Oh. It's exciting. It really is like diffusing a live bomb when you're actually interfering with lithium cells like this. But I do want to test them. I want to actually take this out and put it on test and see if the capacity is what I think it is. Am I still in focus here? Because I kind of focus down quite low. Have I got anything I can bring the focus up with? I shall bring it up with, tell you what, let's stick my favourite focus box down here and focus on that. Why do I focus at specific heights? It's because if you leave autofocus on, it hunts all the time. And you do get different modes that kind of reduce that effect, but it is quite annoying. Oh, here is the little layer of cardboard that sits on top of the protection circuit board. What have we got? What have we got? What have we got? Okay, so this is the circuit board that has the facility. Oh, this is where it's kind of spot welded on. Do I want to break these off? I do kind of want to break these off because I want to break this back down into a couple of smaller packs, the individual batteries. Let me just shuffle my explosion containment pie dish here while I reach the tools from underneath it. And let's try to cut this off without shorting it onto an adjacent pad. Oh, it's folded over. That's not too bad. Can I crop it like that without shorting it onto this one? I think that's me broken the tab there. I'll tell you if something suddenly gets very hot, as tends to happen when things go wrong. Rightio, so now I want to just wheedle my snips in here and get this connection off. No explosive heat yet. Oop. The worst thing when you're taking these apart and things do go wrong is when it starts getting hot and you can't break the bit that's actually shorted out. Ooh, right, okay, here we go, let's lift that up. Let's take the tape off the side and I'll liberate one of those cells. And once I've done this, I will put it on test. I'll basically connect it to a power bank circuit. Oh shit, they're glued together, bugger. Damn. But that's okay because I can actually link these cells together and turn them into one big cell, which is what I might have to end up doing. The tape is off. The yellow tape at the moment is just wrapping around the side here. I don't think it's sticking them together. So I'll take this tape off at the bottom. As I say, if you're doing this, it's better to do it with the batteries discharged, because then they've got less to put out when things go horribly wrong. It's very, very easy to short out lithium cells. And when you do, because of their ability to hold lots of charge and put it out quite quickly, it gets very messy very quickly. Okay, this is slightly annoying. These two cells are stuck together, so I'm going to have to convert them into a single cell by linking across. Let's big floppy bit of circuit board directly above lithium cells and all the other connections. Let's try and not short things out. And also let's not rip the tape out the package. The cell is kind of diffused. Okay, let's work out what polarity these are. So I've got this cell. So this is actually negative at this end. Negative. And the other end is positive, which makes sense. Based on the capacity of this cell, I would say that that is going to be the decider that, you know, if you fancy getting a big cell for like this for £5 out of Poundland, it's well worth it. Okay. Now, it'd be really nice if this was positive as well. Oh, it is. That's nice. Because that means I can just tie them across. I can actually just link those straight across. Positive. I'll just put a wee positive across that. That's fine. So I'm going to put a wire link across both those. Put some more Kapton tape on it to secure everything in place. I'm going to double check everything before I do this. And then I'm going to put some wires on, and then I'll put it in test. And I shall leave a comment in the description down below once this test is complete to tell you what the capacity of this block was if it came up to the 10,000 milliamp hour. So that's it. The Amazon thingy, the sort of little portable charger thingy, the external power supply for running your listening device outdoors if you want to take it outdoors with you under battery power instead of having it plugged indoors. And the things that are worth salvaging from it. So there we go. Interesting stuff. I shall let you know in the description down below. I really must remember to stop turning the camera off just as I'm about to do dangerous things, because they're where the most fun happens. I've tinned these leads. Now I'm soldering a wire onto each. I've pre-terminated this into a little tiny Molex connector. And this will turn this little lithium bean into a beefy lithium cell. One big cell with the two in parallel. Let's make sure those are well connected. I think those look very well connected. So now a bit of Kapton tape just to avoid short circuits. And I shall tape this down. Actually, I wish I'd done it the other way around now. I could do it the other way around, it doesn't really matter. I shall put it over that way, that's actually not a bad idea. I shall tape this down over here with some Kapton tape. Well, I say Kapton tape, it's knockoff Kapton tape, most likely. It's most likely not the original branded version. So I shall put a little bit over there to tape these wires down in position. And then I'll put a couple of layers over the top. I'll probably put a couple long ways and then one sideways just to make sure that nothing can short them. So I'll put one over like this. I wonder what it's like working in the Chinese factories, putting the connections onto lithium batteries. I wonder how many little meltdowns they have in the process. It must happen. Do they have a explosion containment pie dish handy in case of these incidents? And one over the top. That should make it relatively safe. Okay. I'm going to connect it to a power bank charger, this module out of a power bank, with this connector, and then fully discharge it and then fully charge it again, and we'll see what it comes to, and I'll mention that down in the description below.